Okay, welcome back. Right, one of the first questions that you're typically going to get in a calculus test or calculus paper is they're going to give you an f of x function. So let's give ourselves an example. Let's say f of x equals, let's say 2x squared plus x. Okay, we recognize that that's a quadratic equation because it's x squared. And they say to you, find the derivative of that f of x function, and they say by first principles. Okay, now that by first principles means you're going to find the derivative using that f of x plus h formula that we derived in the previous video. Okay, so this is a process. You have to go through it. If they ask you to do it by first principles, you have to follow this method. Okay. So what do? They've given us an f of x function. So if I were to draw that, that's going to be some kind of parabola. So let's I'm just going to very roughly draw it. It would be some kind of parabola. And basically the idea is that if I were to draw a tangent to this parabola really at any point, so whether it's at that point or whether it's at that point, wherever it is, the derivative is going to be the formula that is going to help us find the gradient of that tangent at whichever point at which it's touching on the graph. Okay, so how do we find it using first principles? Well, we go straight to the formula we found earlier, which was f prime x equals limits of h tending towards 0, where f of x plus h minus f of x all over h is the formula. Okay, you do get that on your formula sheets, but it's a good idea to know it well. Okay, now we need to find, using that formula, we need to find the derivative, which again is the gradient of your tangent of the given f of x formula. Okay, so let me just enlighten you a little bit over here. If I said to you, find the value of this particular function of f of 2, okay, well, we've been taught up until now that if I've got an f of 2, then what I need to do is take my f of x function and basically substitute 2 into all the x's of that equation, and out comes the y value. The f of 2 is actually the y value at the point where x is equal to 2. So we're substituting 2 into all the x's, and what we would get is that corresponding y value. If I said to you, what's f of a? Well, similarly, we would take the same equation, and everywhere you've got an x, we would just replace it with an a. Okay? So therefore, if I said to you, what is f of x plus h? Well, wouldn't we be doing exactly the same thing? I'm going to take the equation, but everywhere I've got an x, I'm going to replace it with x plus h. So I'm going to have to write it underneath there. Okay, so when we talk about f of x plus h, we're saying take the original f of x equation, but everywhere that there was an x, you are simply replacing it with x plus h. So just remember that, okay? Now, when we are doing first principles, it is really important to make sure that you're keeping your notation correct, okay? Notation is the way you're laying it out. They do get very specific about that. So the way you want to do it is you keep writing equals and you keep writing your limit where h is tending towards 0. And I'll show you the point at which you no longer need to write that. But at the beginning of each and every step, you have to write h tending towards 0. Okay? So I've got f of x plus h, which was 2x plus h squared plus x plus h. That was my f of x plus h, minus f of x. Now, f of x was just the original f of x equation, which was just 2x squared plus x. And this is all over h. All right. Limits of h tending towards 0. And now it's a bit of tidying up. I need to multiply this all out. So this is going to FOIL out. So we've got 2x squared. That's 2xh plus h squared that's going to be just x plus h, and here my negative will distribute into the bracket to give me minus 2x squared minus x all over h. Okay, right, so now we're going to say equals limit, you can see I'm using that each and every time I start, equals limit h tending towards 0. Again, we're tidying, so I want you to 2x squared plus 4xh plus 2h squared plus x plus h minus 2x squared minus x, and it is all over h. Okay, so all I'm doing right now is I'm just tidying up. Okay, equals, again, you can see I'm writing it again, equals limit h tending towards 0. Now I'm just going to tidy up one step further. There's a nice little checkpoint for yourself at this stage. Any term that does not have an x in it needs to cancel. All right, so every single term that has an x in it, every term that does not have an h in it's got to go. So 2x squared is going to cancel with negative 2x squared. Positive x is going to cancel with negative x. Nothing else cancels, but can you see that that term has an h in it? That term has an h in it, and that term has an h in it. Nothing else, every term has an h in it, so we know that that's what we're looking for. All right, so basically this is what we've got. We've got 4xh plus 2h squared plus h all over h is now what we have simplified this to. All right, now we come to this limit. What do I do with this limit where h is tending towards 0? Okay, now the idea with the limit is that you take the 0 and you substitute the zeros into the h's of your equation. However, having said that, there's a small problem with it as it is, because if I were to substitute 0 into all the h's, I'm going to land up with an equation with h in the denominator. And that I cannot have. Why? Because that makes it undefined. So, before I can take my limit and substitute it into the sum, I need to somehow try and get rid of that h in the denominator. And the best way to do that is, do you see that we've got an h, which is a highest common factor in your numerator? So if I take out h as a highest common factor, all right, we are then left with an h that will cancel with an h, and leaving us with, okay, I'm still writing my limit, h tending towards 0, 4x plus 2h plus 1. Right, now we are ready to take that 0 and we are ready to substitute it into the h of my equation. And it's at that point that you no longer need to write the h anymore. All right, so it's at that point we just write equals, and we say 4x plus 2, but now instead of the h we've got 0 plus 1, and that simplifies then to just 4x plus 1. Okay, what have we just done? Remind yourself, what have we just done? We found the derivative, and what is the derivative? It's the gradient of your tangent at one specific point. Now remember, I said that there's many different tangents that could be applied to this particular graph. So this formula here, which is now your derivative, so let's actually write it here. So therefore the derivative, and the way we represent the derivative is we say f prime x is equal to the equation of 4x plus 1. Okay, so if I wanted to know the gradient of the tangent at, say, that point over there, well, the x value over there is probably around about 1. So what I would then do is I would substitute 1 into that x over there, and we would say then that I would land up with 5. Okay, so the gradient of the tangent at this point, where x was equal to 1, would be 5. If I wanted to know the gradient of the tangent at this point, where x is something possibly like -3, then I would take the same derivative formula, but into the x, I'm going to substitute negative 3. So we'll have 4 times by negative 3 plus 1, that's going to give us negative 12, plus 1, which is negative 11, and that would then be the gradient of the other line. So that this line over here would then have a gradient of negative 11. And we worked out both of those gradients by using that derivative. Okay, so before I finish off here, this is something I want you to become really familiar with. When I use the word derivative, or whenever you hear the word derivative, I want you to remember you are finding the gradient of your tangent. And that is super important to remember. It just helps you to clarify in your head what it is that we're doing when we're working with the derivative. Thanks for joining me, guys, and I will see you next time. We're going to do a bit of practice examples next, so make sure you have got pens and pencils, and we're going to get going with a whole lot of examples just to make you familiar with this concept.